Good afternoon and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen and I'm the Program Manager for the Recycling Market Center, and I will serve as your moderator today. We would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series, and Lisa Ruggiero of the National Recycling Coalition for providing technical support and the delivery and recording of this program. The subject of today's webinar is plastics recycling in the healthcare industry. We have two excellent speakers today, Bill Turpin and Kurt Deska. Following their presentations, we will conduct a question and answer session. Please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you are experiencing technical difficulties during the webinar. And now I'd like to introduce our first presenter. Since 2007, Bill Turpin has been the Director of Strategic Business Development for Waste Management Healthcare Solutions, Inc., a subsidiary of Waste Management based in Houston, Texas. In this position, Bill has developed solutions and strategies to manage healthcare facility medical waste in a sustainable manner. He led the creation of a small quantity medical and pharmaceutical waste management strategy and program with an inside sales team focused on healthcare customers. Bill also led the development of the innovative Ecofinity program with Becton Dickinson, which received the Green Leadership Award in 2011 and achieved an exclusive endorsement by the American Hospital Association of Integrated Waste Management. Prior to Waste Management Healthcare Solutions, Bill worked for Sharps Compliance, Inc., for Caremark as their general manager, and for McKesson as their national accounts director. Bill is a graduate of the Virginia Military Institute. And Bill, you're on.
Thank you. And I appreciate the opportunity, Wayne and team, to talk about the opportunity and the challenge that we're all working on. 3 years ago, a group of industry-leading companies, Waste Management, Becton Dickinson, Johnson & Johnson, Hospira, Baxter, Kimberly-Clark, Engineered Plastics, and Cardinal, got together in Chicago and started thinking there's got to be a way that we can help collaborate to help the hospitals identify and capture plastics for recycling. Let me give you a scope of what we're trying to do and how it can really make a dramatic impact nationally. 1% of all the waste in America is generated by hospitals. You know, these 5,000 to 6,000 hospitals out there, think about that, generate more than 1% of all U.S. waste. 25 pounds per patient per day is generated in waste. It has an annual cost of approximately $10 billion in disposal cost. And 85% of that volume is not regulated waste. And what I mean by that is, underneath that, 15% of 15 to 20% of all the waste that the hospital touches is regulated and managed by multiple agencies. So part of the goal is, if somebody's miscategorizing and putting plastics from solid waste into medical waste, is there a way that you can stop that? It reduces the cost, reduces the regulation, and then it gives you the opportunity to look for other strategies. 15% of that total volume of waste in the hospitals is plastics. So the goal is to move the plastics from contamination into the solid waste stream, and then figure out what are the other things we can do to manage the waste. Everybody at that meeting agreed that there's a significant opportunity to make an impact nationally. And as a result, we got together, figured out there were programs we could collaborate on, and ultimately HPRC was born. And HPRC stands for the Healthcare Plastics Recycling Council. HPRC is a private technical coalition, and then if you go to the next slide, please go. Slide 2 is, what is HPRC? Again, Healthcare Plastics Recycling Council. And it's a group, it's a private technical coalition made up of the industry peers. I'm going to read this because we do this with each other every time we meet. Across healthcare, And recycling across healthcare involved with recycling and waste management industries, and we're seeking to improve the recyclability of plastics products within healthcare. And again, I take you back to the big numbers of 25 pounds a day per patient, 1% of all the U.S. waste, and 15% of the volume being plastics. So it's a significant opportunity. And what we're focused on are what we call pre-patient plastics. In other words, plastics that have not come in contact with a patient, that then don't bump into the regulatory requirements for post-exposure, where it might have exposure to blood or body fluids. So our HPRC is unique in that our focus is on identifying the plastics barriers to recycling and developing solutions across the entire value chain, and we'll get into that in a second. We're seeking to affect the plastics recycling from both a design perspective and on guidelines on disposal and recycling options. The mission that we all came together and created was to inspire and enable the healthcare community to implement both a sustainable, cost-effective recycling solutions for plastic product and materials. And what we mean by cost-effective is our starting guideline is we know hospitals and healthcare is under a lot of pressure to not increase cost and to reduce cost. And so one of our basic tenets is we do not, when we try to look at the opportunities, we try to develop solutions at a minimum that are cost neutral. So we get together a couple of times a year in person, and we also collaborate monthly in conference calls. What we're working on is becoming change agents, this whole group and this whole committee and all the companies within HPRC. We believe as leadership companies in healthcare, if we change our behavior, other people will follow. But we want to become a change agent. We want to increase the amount of plastics being recycled from hardly any today. We want to become an absolute leading resource for the data, information, speakers, anything we can do to help inspire and enable people to recycle more plastics, and provide and have HPRC as an organization. And it's also, you can find it at www.hprc.org. And there'll be lots of information there that can help be an authority for guidance. One of the things we're most proud of is, and it's an example of the collaboration of the companies, we were able to collaborate and develop design guidelines. And Kurt will get into this a little bit later, but there's a lot of challenge in how products were designed, both from a packaging and a product perspective, where you would have a lot of mixed materials. The more mixed materials, paper, plastics, anything else that could be bundled into the manufacturing process, cotton, fibers, that are all bundled together, it minimizes to eliminates the potential for that to be recycled. We also, I mentioned cost earlier. We've been very focused on cost analysis, looking at paper versus plastic labels. We had to get our feet wet. We had implemented several pilot studies we'll talk about in a second. And there's the importance of material safety, material testing to determine A, safety, and B, how the material can be recycled. I want to acknowledge all the key members, and everybody on the committee works extremely hard. It's Baxter, Becton Dickinson, Cardinal Health, Covidien, DuPont, Eastman, EPI, Hospira, SABIC, Phillips, Kimberly-Clark, Johnson & Johnson, and my company, Waste Management. We have all been working on this project now, and we've had several new members join, but the project has been active for 3 years. And everybody plays a really key role, whether it's in product design, communication, partnering, teaming. We have several committees involved. We have a technical committee, we have a leadership committee, and we have a communications team. So we're linked up with these organizations, and everybody shares a singular focus on how do we improve the ability of the plastics to be recycled. Starting off with a value chain approach, if you think about it, how do we improve products for recycling? First off, they have to be designed to be recycled. And whether it's how the plastics are sourced, meaning if we can recover the plastics in a pure way, potentially they can be reused back in healthcare, much like Becton Dickinson and Waste Management have created and collaborated with an eco-affinity program. The goal is to capture the plastics, run it through the recycling chain, and then capture it and bring it back into the use in additional products. Product design and manufacturing, product packaging design has a huge impact. And the more we can get people to make the packaging out of the same material, the greater the volume of plastics that will be recovered. Then it talks about once you create the design guidelines, moving it into the manufacturing process, similar philosophies. As it moves through warehousing and distribution, can you eliminate excess packaging? Then as the product is used and received, again, recognizing every one of these steps in the chain can have an impact on the recyclability of the product. As it moves into the collection and processing, can you create guidance inside the hospital that stops somebody from putting plastic that doesn't need to go into the regulated medical waste stream? Can you, like blue wrap, for example, if you can take the blue wrap before the patient enters a room and any body fluids are around, can you take the blue wrap and put that into a recycling area? That's an example of diverting something from a higher cost waste stream into something that could be recycled. And then it moves to the next area. How do you collect it in a way that it's not commingled? How is it sorted and processed? And we'll talk about all these during the call today. And first off is you look at the availability of the recycled product. Hopefully you're going to focus on areas, and we'll talk more about this, where the volume of the material is significant to undertake the project. And I talked a little bit more about changing the design features. So for example, if the packaging is paper and plastic together on a sterile pack, changing it to all of one material. And we're also looking at creating some guidelines outside of the packaging so that people can understand visually, is this package recycled as a plastic or as a paper product? And then we talked a little bit about changing the practices, both from a sourcing perspective. In a perfect world, we'd like to be able to take the materials that we're recycling and be able to bring it back into sourcing so these materials are used back in healthcare. Just mentioned an example on the labeling, for example, so that we could put more visible labeling on the packaging so that people can understand which waste streams the packaging would go into or the product would go into for the proper recycling. Next, please. One of the really key components here is the availability of infrastructure to support a recycling effort is highly localized. And so we're working to create directories and roadmaps and information and guidelines to help people understand if you want to start, when you want to start down this road, because I don't think it's if you want to start down this road, it's when you want to start down this road. You need to understand what are the resources in your community or your area, and what type of materials can they handle. For example, there are large volume Murphs that are set up to, and Kurt will talk a little bit more about this, to handle large volume plastics for the consumer market. And there's a differentiation between flexible plastics and rigid plastics. Understanding what are the resources in your community. Another key area is health and safety exposure. Can you ensure inside the four walls of the healthcare facility that they're going to provide and you really have to manage and stay on top of it, that you're not going to contaminate the material that you're collecting. In other words, if your focus is pre-patient plastics, you don't want post-patient plastics or medical waste entering into that. Understanding the processor capacity in your market. A lot of the manufacturers and the group folks in the team are also working with educating the processors to have them understand that some of these materials are highly desirable for recycling. And in terms of setting a market value right now, the goal is to transfer the material from the solid waste area into something that could be recycled. The goal is not to increase the cost. Down the road, as we're able to gather volumes of the material, and Kurt's one of the ones he'll talk a little bit more about this market value and the opportunity to create value for the material. An important part of our team are the HFAB members, the Healthcare Facility Advisory Board. And I would say they're critical members, and really want to acknowledge Stanford University and Kaiser Permanente as key members who joined our team. We realized we needed and we call this sometimes dock-in knowledge, people that work inside of the hospitals and how to make it work in a hospital environment. The HFAB members help us understand the barriers that exist within the facilities today. They help establish the priorities for the technical data, and they're also working to develop the solutions around data, information, and resources. So Stanford and Kaiser were the first two to step up. They've been very aggressive in implementing new programs. They're nationally recognized as thought leaders, and want to take this an opportunity to formally acknowledge how valuable they are to HFAB, as HFAB members to HPRC. So the design guidelines, this is one of our first outputs, and we actually took the time to focus on how do we change product and packaging design to enhance the recycling value. And this information is on the HPRC.org website. We want to acknowledge the Cleveland Clinic, Engineered Plastics and Waste Management's role in going through the initial study to collect the materials coming out of a hospital to find out what's recyclable, what's not. And based on the findings in the early work with the Cleveland Clinic and Engineered Plastics, we learned a lot of important lessons, and realized that a key step is we've just got to change the packaging design to improve recyclability. Pilot studies collected various materials, volumes, all types of plastics within the healthcare facility. We approached it initially trying to say, let's go big and see what we can collect, and then whittle it down from there. And that included almost anything that we could identify from a plastics perspective. Large volumes of material would have been blue wraps, pour bottles, and we started testing and defining what materials would be able to be mixed and blended in this program. Again, the focus was on non-patient contact plastics. And this will be my last slide, and then we'll hand it over to Kurt. But think about this inside of the hospital when you're trying to start a plastics recycling program and how you want to implement it. And this is going to be the second guideline and tool that we will publish, soon to be published probably within the next week or two at HPRC.org. And this is a cookbook on how to implement a recycling program inside of your hospital. You want to think about before you begin. Commitment from the hospital, senior leadership. You got to have the infrastructure in place. Look at the timing compared to other projects. Are there any regulatory requirements in your local area that might impact the success of the program? The initial economic analysis, making sure that you have the budget to be able to do this in a way that is acceptable to the hospital. Look at your different business haulers, and processors. What's available in your market? And we are going to include some guidelines and links to this on HPRC.org. Looking at what materials the Murphs and the recycling centers will accept. Develop an implementation strategy. refine your economic analysis and budget. And then what are your key performance indicators that you want to achieve at the end of this project? Space and logistics when you're running the program. It will take additional room and storage at the facility, whether it's at the back dock, you know, how are you going to, where is the material going to get baled or condensed? You want to avoid contaminations, and this is really important because people will make mistakes. You have to plan for a contingency. Should somebody accidentally contaminate the material, how are you going to manage that? Separation, identification, and have people understand you're not in focus on infectious waste, but if it's contaminated, you want to make sure you've got the plans in place. How are you going to handle the non-conforming recyclables? Safety is always important. What's your key performance indicators so that you can share and celebrate your success? And it's train, retrain, and then going back and improving the program. It is absolutely a continuous process improvement. You'll start with materials that you can segregate early and easily and well, develop the process and the procedures, and then you'll want to start layering on. And good, strong communication process with your local business partners and stakeholders. And with that, I'm going to hand over to Kurt.
All right, thank you, Bill. Our next presenter is Kurt Duska. Kurt is the president and owner of Engineered Plastics, LLC, with 4 facilities totaling 230,000 square feet and 175 employees. Kurt has achieved success with 25 years experience in tooling, molding, and assembly. Kurt holds a BS degree in Industrial Engineering and Management from Gannon University. Kurt's accomplishments include a founding member of the Pennsylvania Recycling Market Center in 2005, receipt of the Environmental Company of the Year Award by the Northwest PA Small Business Development Council in 2008, receipt of a Pennsylvania DEP grant for $500,000 for recycling equipment in 2008, the initiation of a medical recycling program at the Cleveland Clinic in 2009, a founding member of the HPRC in 2010, receipt of the Governor's Award for Environmental Excellence in 2011 in recognition of his post-industrial plastics recycling from waste to profit initiative, and founding of EPI Recycling Solutions in Sanford, North Carolina of this year. And Kurt, it's all yours.
Thank you, Wade. Our group, we had to learn what to do, and we went in with a blank piece of paper into the Cleveland Clinic. And it wasn't engineered plastics going in or waste management, it was the Healthcare Plastic Recycling Council. And we went in with the credibility of having the manufacturer, having waste management that already had the relationship at Cleveland Clinic, and ourselves handling the niche recycling. So although we know what the materials are, we understand collection, we didn't understand the hospital situation. So what we had to do first was develop, design, create a system that will allow us to start bringing in these materials, products, and see what are the best products to target. And this didn't happen on day one. Between ourselves, waste management, and others, we were in there probably 10 visits before we started up the program. So we had to work first to define a safe program that would have the least amount of risk. That's why, as Bill mentioned, we're focused on pre-patient. So before someone is cut, before the fluids are flying, hopefully our material is going to be removed before contamination. So that eliminates risk both for the internal logistics, handling inside the hospital, for the hauler, and then for the recycler. Also, we're looking at higher volume items because we can't take small volume items. It does not set up for a profitable model. So we're looking at easy to handle items that have valuable material. And then also we have to remember that the primary focus of the hospital is to care for patients. So we have to define and develop a system that is not, that doesn't take away from their core responsibility, which is taking care of the patient. So as we developed this trial, and it was very much a pilot study, we worked with them to define what materials we're going to take. So we had a go and no-go list of products. These are the targeted items we're going to go after, and these were by our best guess. saying, after doing some initial studies and understanding volumes, materials, logistics, okay, what are we going to target? So we put together a list, and of these items, you could see on our initial pilot study the results that the polypropylene sterilization wrap, which we're going to go into more detail in the next slides, but the polypropylene sterilization wrap, all instruments are wrapped in that. So when they go through sterilization, it's a high use item, very clean because it's removed before surgery. It's easy to identify. Plastic pouches, polybags, almost everything is wrapped in plastic to be kept sterile. PETG trays or PET trays, or sometimes it's PVC trays, as we found out. We received a lot of pouches that had paper backing, which we didn't realize were going to be mixed into the stream. A lot of rigid containers. A lot of it is irrigation bottles with sterile water, which are great products for us, but it also did give us some issues trying to understand how it's handled through. Polystyrene trays, phenomenal material for us to recycle, but to make sure we can identify what it is and not to have contamination on it. And then we received other items, paper wipes, paper, foil packaging, and other miscellaneous items. So when we identified our product, we wanted to say, okay, what we're going to get in, and we're going to study this. So every load that came in from Waste Management that they collected, they came into our facility in Erie, Pennsylvania, and we would take that material and take it apart and weigh and verify and look and see what materials are coming in. At that, we started to understand what the hurdles were, what the struggles were for us to create at least a cost-neutral position for the hospitals to recycle. It wasn't easy, very painful, and it was constant communication to provide a safe program for all employees involved. But it was a true pilot study that we learned from. Now I want to go into some of the detail. We received in sterilization wrap. The industry, I think it's about 25 million pounds of sterilization wrap is used in the United States each year. And this wrap, it's a non-woven polypropylene. Instruments are put in for sterilization. If you see that piece of tape on it that has the black lines on it, that's a paper-based sterilization indicator tape. And when this product goes through sterilization process, when it goes up to a certain temperature for time, the black lines come up on the tape and they show it. If the lines aren't showing it, it is not a sterilized item. Also, they put paper identification on it, or it could be the doctor, the patient, or the procedure. So if you look at this one specific item, this is a non-woven polypropylene. And as it's used, they're applying, and we figured it was about 2.5% to 3% paper tape. And then we also had paper labels on it. So our issue was we had a beautiful polypropylene, which is great for us to recycle, with 3 to 3.5% paper, which really took away from the recycling capabilities and lowered the value. So looking at this one item, our issues were that this created an issue because we could not afford the labor to remove the paper. It wouldn't be cost effective. And because of the amount of paper, the contamination brought down the level, the value of the end product of the polypropylene, and it also gave us many processing issues. So, looking this as our group and our design guidelines, remember, recycling doesn't come by accident. We have to design for it. So what we're trying to do as a group, and we've been focused on it for last year, is to remove the paper. So if we can go to a plastic tape, a polypropylene-based tape, and maybe a polypropylene-based label, all of a sudden, all the material is polypropylene-based, which improves the value of the material and makes it much easier to recycle. Now this is a very simple item. If you look at this as an irrigation bottle, and a 1 liter bottle in the United States, 8 million are sold each year. It's about 400,000 pounds of plastic. And we're looking at 2 different style bottles. They both handle the same material. One thing is they both have paper labels. As I think you understand from the previous slide that paper is bad, plastic's good for us. So when we take this material, we look at it and go, what are the issues? So first of all, this is a polypropylene irrigation bottle, and it has a paper label. So in our process, we either leave it as it is, which lowers the value, or we have to grind this and wash to remove the label. But if we can change that label to a polypropylene base, or removes that requirement for the additional processing, which decreases costs, which improves the effective capabilities of the recycling program. Also, on some of the saline bottles, some manufacturers use a rubber-based silicone seal, while others use a thermoplastic elastomer seal. Now, the TPE seal can be recycled directly into the polypropylene. With the non-plastic, the rubber seal, that has to be separated or it will lower the value. So as a group, and if you look at the size of the manufacturers involved, that we have about 80% of the industry on irrigation bottles. So if we can get these two companies to consolidate, to design similar, it's going to improve it. And also in our design guidelines, if we have all companies coming out with new products or reviewing our design guidelines, they will create a comprehensive program where they're all the same, and that's key. Could you imagine if every water bottle, if every manufacturer created a different water bottle out of a different plastic? So that's what we're dealing with here. This is where it gets interesting. While we are very capable of recycling plastic films, and Tyvek we love. Tyvek is a polyethylene-based material. The reason they use the paper needs to breathe during sterilization. Tyvek is a breathable plastic, which works perfect for it. But in the industry, there's a mix. So certain plastics, bags will have a Tyvek patch, some will have paper. The problem is that no one can identify it. So for ourselves, for us to improve the recycling rate of these bags, that we need people to standardize on products. Now, I don't want to say I'm strictly pushing Tyvek, but we need materials that'll improve the recycling rate. Also, some method to identify these materials. It is extremely difficult to tell the difference between the Tyvek packaging and the paper. And the paper, all of this is a contamination. When we get over 3% to 4%, it starts to shut down our system, the recycling process. Materials we love. If you look on the left, the polystyrene tray. Very easy for us to recycle. Fairly standardized in the industry, how it's used. Not always identified properly. Things that would make it easy for us is if the polystyrene trays were all white. Or they're all marked a certain way so we can identify. While they may have a small number 6, it isn't always cost effective for us to take a look at every tray. The item on the right is the PET tray. We see many clear trays. Some are PET, some are PETG, and some are PVC. And those of us in the plastics know that mixing PVC in with it could be a major issue. A lot of these PET trays are used for endoscopic tooling, for high-value tooling for the protection of these devices. And a lot of times they have a top seal of the DuPont Tyvek material on top, which is 100% recyclable, great item. So if the industry was to focus on a PETG, which is a majority of the industry, with the Tyvek, it would drastically improve the recycling rate. But it is key that there is identification difference between PET and PETG. In some of the standard items that we receive in, almost every box of products that comes into a hospital has a bag liner. That bag is a low-density polyethylene. It's very easy for us to recycle. Also, the stretch wrap that goes around the skid is easy product. So don't be afraid to go after the easy products. The hard ones take a lot of work. So we focus on items that had high volume, high value, and will allow us to blend in the stream. While we were running this pilot, we brought in everything and we started segregating the products. And we would have at least a couple percent, up to 10% of non-conforming items. So you will have a foil-backed film, which, because of our magnetics or metal detection system, would set off all the warnings. And then we get in a lot of items that are just not recyclable, whether it's foil or paper, aluminum, or multi-material items. the trick is trying to identify materials that we could target that are easy for the hospital. So we have to look at this as a non-plastic person, have to understand how it's being used in the hospital, and the easy identification system for a nurse or whoever's involved with this to target a specific product and to put it in the right container. It was not easy, and we had to do multiple lunch and learns to share the information of what we're looking for, what the issues are. But that's where the continuous work of waste management going in there and ourselves going in there and explaining and showing these pictures of the non-recyclables, which allow us to improve the value of the product. Also, everyone thinks latex gloves are plastic. Well, we can't recycle them. There's a lot of different types of foam, paper, and other items. So even though you identify a system where you say, I am only taking this, and here is what we're going to take, wrong material gets in, whether it's a Murph, whether it's a curbside Murph, or at a hospital or post-industrial. You have to plan, as Bill said, you have to plan for things that go wrong. And that is where it's key to have a partner like Waste Management that understands the issues, and if we do have a glitch on it, that we know the proper way to handle these products. Our first concern was to develop a safe program for all involved. And this pilot was, we did learn some lessons of, what is the potential ick factor of material coming in. While everything is recyclable, it doesn't mean it's cost effective to recycle. So if it's not cost effective, it's not sustainable. So our focus has been, as a group, to define a process that will be repeatable anywhere in the country. Thinking more of a franchise model, that if there's a recycler in an area that has the basic equipment to process it, this is how they could do it. So if you look at a product, a PVC flex hose on the right with all those different fittings, those fittings could be polycarbonate or PVC or ABS or polyethylene. We have no method to identify, although we could scan, but it isn't cost effective. So we're very focused on the simplest products that would allow us to make the greatest impact on the recycling stream. So what did we get? What was critical is that we could densify this product. Logistics usually limits the recyclability of a product. So even though you can recycle it or you can pick it up in one area, if you can't economically handle it to take it to the processor, then you can't afford to do the program. The advantages with our relationship between Waste Management and Cleveland Clinic, that we could bale it at different locations. Whether we baled it at Cleveland Clinic or Waste Management, we had to get this to densify. One bale that we're running in a downstroke vertical baler, we were getting between 700 and 900 pounds, and you can see the mixed items. You see blue sterilization wrap, you see irrigation bottles, a lot of film, bags. This material was a blended single stream coming from the hospital. This material loose would take up an 8-foot by 10-foot room. So when we expanded this, it took up a massive amount of room. Also, if you look at it, if you don't densify, you're not getting many pounds. And recycling depends on pounds moved, not volume. And I guess I forgot to fill in these, what is this piece of equipment, but we'll go from there. This is a standard recycling process. What we're using is a densified pelletizing piece of equipment. This is at our facility. This is a REMA recycling system. And on the left side of it, it's our feed side where we're bringing material in. With our product, we ran in a mix of blend of polyethylene and polypropylene because of the multiple materials. So we were very focused on a blended stream that had multiple contaminations of paper and silicone, and this equipment allowed us to filter out most of it. So we're putting this on as a mixed conveyor, goes into our system where we densify and shred it. We're heating it up to 450 degrees. The advantage is running it up to that high a temperature sterilizes the product. Our product was defined to come in as safe as possible, but an extra safety feature of our processing method that we're bringing up the heat to eliminate any biofactors. Then we go through extrusion process. It goes through filtration, degassing, and then through a water ring pelletizer where we're pelletizing the material. And when I say mixed load, that's definitely what you see. This actually is a little bit higher low density polyethylene than the stretch wrap, but as we spoke about earlier, that over 50% of the stream was a blue sterilization wrap, which allows us to almost take that stream out completely and sort and segregate it. So what we're doing is we're feeding the material onto a conveyor. It goes through metal detection, and then we have to go into our system. The problem is one small piece of metal will shut down our system. Very, very cautious so we're not doing equipment damage. So you can see why issues of a metal component, scissors, anything like that will cause our system to shut down. So after running our pilot study at the Cleveland Clinic for a year and working with all our host manufacturers, we worked and said, what are the issues, what are the struggles, what are the hurdles for us to recycle it? And it's not so much, not just at the hospital side or the outbound side, is we need to design for recyclability. As I said before, if water bottles were all made of different materials, I don't know if we'd have the recycling rates we have for it. So what we're focused on is to eliminate multiple material types within one discrete product. Thinking back to the sterilization wrap. If that sterilization wrap is polypropylene based and we can have polypropylene based tape and a polypropylene based label, it drastically improves the value of that. If it improves it and creates higher demand is a higher value, which allows us, we can incur more costs on the collection side, sorting and processing to sell this. Multiple material types within one packaging. If we remove that rubber seal and go to a thermoplastic elastomer seal, it allows us to decrease the cost for sorting or handling. Paper. As I said, paper is bad for us, so we have a huge push as a group. And actually, we meet every other week on paper and label elimination or reduction. We're looking at methods for identification. One thing, it's difficult for us to identify a product, so to better understand it, and maybe it's standardizing, saying all polystyrene is white and polypropylene is blue. Things that make it easier for the recycler, which will improve the recycling rate by decreasing the cost. Some of the items are just difficult to drain. So for us, the more fluids we can drain out of it, it is easier for us to recycle. Minimizing pigments may not sound critical, but plastic has more value the more uses, potential end use. So it's something that's light, natural color, something could be colored as a post-industrial plastic has higher value. So again, our focus, removing the seals, the chemically compatible plastics, removing paper, the monomaterial. The Tyvek is a huge push for us in the breathable plastics as an alternative to paper. But we need to identify it. We need to get people to standardize on that. Bottles and bag design that can be easily drained. Irrigation bottles are fairly easy to handle, but if you look at different methods, different bags, different uses, it can be very difficult to drain, and that excess fluids will cause processing issues. While we, as recyclers, may have things that we want, doesn't mean it's always possible. Certain thermoplastic elastomers cannot replace all rubber seals. And with the new work done in different materials that we see opportunities. So we're always looking as a group at new materials. That's why we're excited about having DuPont and SABIC involved, that they're showing us the newest materials coming out and seeing how we can relate some of these hurdles. Multiple materials. So if you have polycarbonate and ABS welded together, glued together, it's going to be very difficult for us to recycle that, and it's going to have very low value. Metallized plastics are very difficult. While we can recycle metallized plastics, if it's in our standard stream, it causes issues because we're detecting the metal in case there's a knife or rigid plastic or rigid piece of metal coming through that could cause damage to our machines. So as a group, we have to be realistic, saying this is what we want, here's how to make it better, but it doesn't make it possible. Also, we have to look at costs. If it significantly costs more to create packaging just because it's recyclable, and the hospital doesn't see a favorable effect from this, it's probably not going to happen. So everything we're looking at, and we're looking at the total picture. Maybe it's not always just packaging cost, but we have to look at what the packaging cost is with labor for the protection of the product and then the recyclability. Now, as I said before, on our first pilot, we brought in some lower value material. The material on the left was before we made changes. And I'm not saying that all the design guidelines are into effect. We have designed it. We know what we need to do, but we have to do product testing. We have to make sure we go through proper procedures. But if we do put in effect the changes we want to make, the material at the right you can see is a much higher value material. It's an extremely clean stream where we're eliminating many of the contamination. It's a better processing material. So our focus is, as a group, is to improve the end use material by decrease the cost and decrease the contamination. So why are we doing this? It is a definite advantage for the hospitals to recycle. Our goal is to put them at least in a cost-neutral position. It is becoming mandated, especially starting in California, and Bill can talk about this a little, that hospitals need to improve their recycling rates. So we're working with them before it comes into effect. And if you look at the recycling of plastics, we use less, it's 60% more efficient to recycle plastic, uses 60% less energy than to create new plastic. And every 1 ton of plastic recycled saves 16.3 barrels of oil. Also, we're pulling material out of the landfill. So it's a win-win situation, but we need to design for it. Just like the old soda bottles, 2-liter soda bottles had a polypropylene or a polyethylene-based cup on it with a PET bottle. That design has changed. That's what we're doing now. We're looking at making design changes that make a long-term effect. So our current initiatives in our technical committee, which I've been on for multiple years now, is the implementation of design guidelines among the member companies. While we created the design guideline, now we need to implement it. And also, this is a living document. So we're learning as we go, as we do pilot studies, as we learn more from Kaiser Permanente and Stanford about materials and products and goals, that we're increasing the information that we have in there. And then hopefully other companies will follow. So we will get a standardization in the industry on design. So working with Penn State University and Rutgers and RIT, that we're sharing the information with these students that are going to understand. They're going to look at not just designing products for the use, but design it for recyclability. Now we're doing cost analysis. So we're giving the companies the tools to design a cost-effective packaging. So if we can find different plastics that are more cost-effective or similar to cost in paper, then we could show them that it is a value for their customer, the hospital, to go to this packaging, then it definitely influences their change. That we're constantly doing pilot studies, and this is to better understand the industry and to see what new products are coming out, so we can look and work on the design and creative design for improving recycling. Material testing, that we're bringing in those materials, and we have a great relationship with Penn State University in our area, that we're bringing these materials in, we're recycling them, and we're trying to find the highest use for it. So we're trying to create a demand for the product. So we're not just dreaming about this, we're saying, what can we do to make a difference? So we're involved completely in the design chain and trying to reutilize these materials maybe back into our host manufacturers' programs and products. And that is it for the technical. It has been a struggle on the pilot, and we have learned a lot from it. But pilot studies are pilot studies. And every mistake we made, we learned from. And we're hoping that the information that we brought together will make an impact down the road.
Thank you, Kurt. We're now going to field some questions for our presenters. Again, if you have a question, please enter them into the GoToWebinar dialog box. We do have a few questions already, so I will try and explain the best I can. The first one is quite long, so I will paraphrase to the best of my ability. The question deals with, it's a rural county with 2 hospitals. They set up a recycling program for the traditional cans and bottles type materials, and they work closely with the maintenance and environmental staff. The question is, do you do the same thing with these other materials?
Yeah, Bill here, Turpin, I'll take that one. First, what's important if is part of this whole process, and that's where if you stay in touch with the HPRC.org, and when we release this, how this next level of how to implement a program in your area, it's going to be really important to find out the appetite for the materials in your local market. And you can link up with us at HPRC, send us an email, and we can help you find the resources. But again, it's a capacity within the region to consume the materials. Some areas are more advanced than other areas, and so it's really going to depend on that. For example, if you're in Pennsylvania and you've got Kurt there and some other options, if you're in some other markets, they may not be as advanced.
Yeah, the other comment of that question was they're in a rural county and they don't have the Murph that can handle these types of materials.
Yeah, and so it may be what we're finding in some of those, it may be starting simpler. Maybe it's, as Kurt suggested, blue wrap and some complementary materials. But again, you have to have the people on the dock outside who can help handle the material and how it's going to get densified. And because it starts off with no value and a cost, moving the material very far can really negatively impact the economics very quickly. So I hate to give them it depends, but the size of the hospital, the volume of the material created, and the proximity to a recycling option that would handle it, those are all really important economic considerations and business considerations.
The HPRC is strictly involved on pre-patient medical plastics, so we're not involved on the the standard post-consumer items where you have waste management type that will have a post-consumer stream. So our stream is very focused on medical plastics. While we will help to give you guidelines and assistance for that, our focus is strictly on medical products.
Okay, thanks. Are the initial pilot study results based on number of items, volume, or weight?
Kurt, you want to tackle that?
Sure. It was based on weight. Looking at that, it's very difficult to focus on volume, even though plastic is very expensive to dispose of because it's light and bulky. But all our study was done on weight, and it's slightly skewed because we're focused on certain items and certain target areas, which was pre-patient and surgery suites. So different areas of hospitals, different hospitals with different procedures are going to have a different blend. But we've seen a majority. The non-woven blue sterilization wrap has been a high point, high volume item, followed by the other streams. But I would say they're all within a few percent of what we've seen.
Okay, next question is, were you aware at the commencement of this pilot study that the materials you were looking at were almost impossible to handle by the vast majority of Murphs because of the storage space for these items before being able to bale them in sufficient quantity by the processor?
Yes.
Okay.
Yeah, that's part of the challenge. Is typical Murph is designed for rigid materials and post-consumer, and so when we started looking at this, it was how do we design for recyclability with the resources in the local market, And so if you can create segregation of the materials that the Murph wants in the hospital, for example, if your Murph wants rigid plastics like Kurt talked about, trays, basins, pitchers, then you want to design to use the local resources and make sure you touch base with the Murphs so that they can see and know what would come and identify those materials that fit into the Murph infrastructure. The things that fall out of that, the flexible material, the blue wraps, then you need to look at an alternative strategy, and is there a way to bale it, and where would it get baled, because most Murphs aren't going to have the room to deal with it. And so each one of these, again, is a localized strategy, and you need to have enough volume that it generates, that it's worth starting down that rail, on that path.
Next question. Local nurses say they're told to throw everything out, including plastics, because they are contaminated. Is this true? And how do you deal with this?
Education. We've developed and are developing, and we'll have on the HPR website, posters and information and tools, and that's part of also the HFAB member piece with a Stanford and a Kaiser, where we can help them link up and know hospitals that are doing it today, how they're doing it, best demonstrated practices and guidelines and information sheets. So yes, we are aware of that, and we're providing tools and information and networking to help get it started.
Are there any efforts going towards making some items biodegradable, like Chux? That's spelled C-H-U-X.
I'll let you have that one, Kurt.
We're concerned about the biodegradability because it could have a potential contamination to our existing stream. So I think it's important to look at the different uses. So something that is going to be a contaminated item that is going into a landfill, it's probably a great opportunity to go to a biomaterial, a compostable material. It depends on the product. So we need to understand what the products are in the target. So it may be that the cafeteria items, you want to go to compostable, but it might not be the best choice in the surgery areas.
Okay. This one's more of a comment. Basically, they're expressing a need to have a follow-up webinar on how people can control the volume when you don't have balers. How are you going to get it out of the hospital and storing it until it is moved to the vendor? And they would love to see several examples of this. We are, just so happens, the Recycling Market Center is going to be holding what we call Technology Tuesday webinars, and this would be a potential topic to address. So, but in the meantime, Kurt, do you have any comments on this?
Our big push is to get balers in the companies. A lot of the companies are baling their cardboard. We utilize the same process, same equipment to bale plastic. It usually takes about 8 or 9 large Gaylord boxes of this product to make one bale. So you see immediate reduction of volume by baling, but not every hospital has room to store it. So when hospitals are designing, LEED certified hospitals, they should be looking at their material flow outbound, and we're seeing a lot of issues. It's not always not the best solution, at least we believe, to put in with the post-consumer items, because we had chances for higher contamination and issues with glass and other materials. So there's not always one path. You may want to look at whether who's doing your waste, who's doing your recycling now, and maybe working with another vendor, maybe a Cardinal Health or someone is coming into your facility. Maybe they can take product out, or it may be your linen service. So you really have to look and understand what the potential is to find an outbound process for this.
If a recycling vendor would not pay for the healthcare organization for the recycled material, such as polypropylene blue wrap, is it possible and or typical to have the cost of the baler and transportation subsidized by the recycler?
As long the recycler will subsidize the equipment as long as I make money on it, to be honest. So our focus is, if I could help improve the value of the product by making design changes where it's more profitable for the recycler. More recyclables are going to get into it. So you're going to have recyclers that are going to handle those smaller areas. So that's why it's critical for us to do these design changes to make it easier for the recycler.
And this question, this person missed part of the webinar, but they wanted to clarify if the with design for recyclability, are you expecting that all Murphs throughout the U.S. should be able to take these materials mixed together? One of the major barriers I've experienced in working with the hospitals is separation.
Kurt, you want to handle that?
Well, we are seeing advancement in technology at Murph's, but I don't think that in the near future that this post-medical single stream is going to be typical to go into Murph's. The Murph may be the right point for collection, consolidation, and baling, but I don't think they're probably going to be the end sorter. That's where it's critical as our group, the HPRC, that we're developing process procedures, best methods for the recycler and the hauler to understand this. So if we could create a model where it's profitable, let's say in Erie, Pennsylvania, working with the local hospitals, we could share that information, and so other areas. But as of right now, because of the flexibility of the flexible products and the multiple materials, the standard Murph is not designed for those products. It's designed for the post-conservator curbside.
Is on-site granulation feasible?
Yes, I never seen a hospital that was interested because of the specialty of the equipment, probably some of the risk, and then you have to do more sorting. We have seen other equipment. There's some equipment that'll roll it, make about a 25 to 30 pound roll. So there are different equipment out there. There's smaller balers that are easier to use. It's going to be dictated by your volume, your size, could be power, and how much labor and expertise you have to throw at it. Anything's possible. It depends on what you want to do and what you want to spend.
Have you considered plastic fuel or other energy-related recovery?
Waste management has. We've got under a business group in waste management, the organic growth group, we have investments in a business, Agilex, that converts plastic back to oil, fuel, and another one that spec fuel that will take the mixed plastics and convert it into a cleaner burning alternative to coal. So we see some of these new emerging technologies starting to enter the market, but they're new and emerging. And so that's where it's important to understand the resources that are in your markets and what's available. So traditional recycling versus fuel or biofuel type options, or alternative for coal options if you have higher levels of contamination, like paper.
Okay, I think that's it for the questions, and I believe we're at the end of our allotted time. Thank you again, Bill and Kurt. This webinar, like all the webinars in this series, has been recorded and will be made available on both the National Recycling Coalition and Recycling Market Center websites. Again, thank you for joining us. We hope you'll join us for next month's webinar scheduled for Tuesday, August 21st at 1:30 Eastern Time. Have a great day.